This is a program for a cows and balls game that some of you might remember from the GCSE practice coursework, and you'll notice that it's made out of, this is written in Visual Basic, and in Visual Basic we have these things called subroutines. This one here, for example, starts at private sub, ends with end sub, and this carries out a task. And then if I look further down, I can click on the minus sign at the side here to kind of close up the code. And down here we have a function, and the only difference between a function and a subroutine, apart from the keywords, is that functions return values. So this one here returns a string, and we use these to break up the program into smaller pieces that are easier to work with, which you remember is called decomposition, and also to hide the complexity of the program, which is abstraction. Now the kind of point, the key point here really to take note of is that programs are divided up into subprograms, subroutines. In languages like C, these are everything's a function, but in some languages we also have these things called procedures, which are really functions that do not return a value. And that's a key concept to remember about when you think about the scope of variables. So we're going to be talking about scope of variables right now. The first thing to understand is that we have these things called identifiers, and identifiers is simply a name that we give to something, and we give identifiers to variables, to constants, to subroutines and functions and procedures. Each language has its own unique set of rules as regard to how these things can be named, but generally most languages prohibit identifiers from starting with a number or a symbol, and most also prevent you from using spaces. But the key thing from our point of view as programmers is that we should always give them meaningful names. So it's pretty obvious from the name what the variable or item is about. Variables quite a bit. Variables hold values that the program wants to use, and the key thing for you is they have an identifier, and this refers to a memory location. We also have this data type, and the data type tells the computer how big the data is. Also, it specifies something about the nature of the kind of stuff that we can store in this variable. But variables, as the name suggests, they can change while the program's running. Now, we also have these things called constants, which are very, very useful to use. Constants have an identifier and a data type. They also have a value. And the important thing to understand is that value is stored in a memory location, but that value is fixed. It cannot be changed by the program. Now, all variables and constants should have meaningful self-documenting identifiers that describe what goes on in the variable. And you need to understand right from the very beginning that if you choose your identifiers sensibly, the code becomes much easier to understand. It becomes self-documenting. You will notice we have lots of comments in green, and this is the kind of thing that as a developer you should be doing. You should be putting comments in that explain what the program is doing. If you use your variable name sensibly, you'll need to write fewer comments. Now, when you're using variables, it's very important that we initialize them, which means we give them a starting value, so we know kind of on what basis we're working from at that point. And this means that when you rerun the program, or when that subroutine is called again, code starts running from a kind of known point, and that helps cut down on errors. And as it says down the bottom there, a tip is to initialize variables when you declare them. All variables also have this thing called a scope, and we can either have a scope which can either be local or global. So with a global variable, we define these at the very, very start of the program, and they can be used anywhere within the program. They sound ideal. Local variables, on the other hand, are defined within blocks. Now, a block of code could be an individual function or procedure. We can have them, the blocks can be even smaller than that, as we'll see later on. But the important thing to understand is that you can declare a local variable which has exactly the same name as a global variable. And if you do that, then the local variable takes priority. In other words, it overrides the global variable, and while you are running that kind of block of code, it will ignore the global variable completely. And that may be a good thing, or it may be a bad thing. Now, generally, we would want to avoid using global variables for all sorts of different reasons. Part of the reason for this is that if you only use local variables, it prevents you from accidentally changing a global variable and setting it to the wrong value. You also know where you're starting from, so it's like you're going on a journey and you know where you're starting from, rather than starting at some random point in the middle and not being really sure where you start from. And using excessive use of global variables can lead to rather irritating problems, like, for example, if a program runs correctly when you run it the first time, but then if you rerun it or just press the button again, it doesn't run correctly second time around. That is quite often indicative of an uninitialized variable, or using a global variable where you should be using a local. So anyway, what we're going to do right now is look at how you actually define these things. Now the example I've got here is written in visualbasic.net. So you'll notice that what we've done here is we created this thing called a module. Now you can have modules in C programs as well. So in this program we've got, as you can see, that's different parts in it. What we did is we went onto the project menu and said add module, and it's added this thing. And what we can do in here is we can declare these variables. And the really good thing about this is like super global, in the sense that it can be used by any part of this program. So this program could have maybe 50 different forms in it, and every single one of those forms could see a variable called a global variable, which is obviously not a great name for a global variable, but the point is it's kind of visible throughout the entire application. Here is a Visual Basic program. It's really doesn't actually do a lot, this program, but it has a number of buttons. We can see that because we've got the buttons down here, which are very badly named: button 1, button 2, button 3, and so on. When we click on these things, it gives us the value of it writes a message on the screen. And you'll notice at the top here it says public global variable as integer, so we've declared a global variable. This variable here is available to all of these blocks within the program, and that means that we only need to define it once. Now, what happens is when you run a sub-procedure, so it could be a function or it could be a procedure, what will happen inside the computer is it will first of all take all of the variables that are local to that procedural function, and it will allocate memory for those on a data structure called the stack. So the stack increases in size, and then when the sub-procedure exits, so when it ends, that storage gets deallocated and the contents of the variables gets thrown away. So you can kind of imagine this stack as kind of the top of the stack is going up and down constantly as the program is running. Now what this means is that when you exit a subroutine, the variables are deallocated. So up here at the top we've got a subroutine called button 1 click, and it has a variable called button 1 variable, and we put a value into that. We then refer to it in this first message box statement here, we refer to it in the second message box statement, and the third statement down here. So we can use that throughout there, as you can see, and there's no problem with that. However, at the bottom of the screen down here, we're trying to use that same variable, but that's generated this error, which is what the red cross is about. and the reason we've got that error is because button 1 is local to this top routine. So this variable here called button 1 variable will be allocated when button 1 click starts, deallocated when we end that subroutine, which means when we start button 2 click, there is no variable allocated called button 1 variable, and therefore that generates an error message. You notice down here though, we've got this routine called button 2 variable. We could quite happily refer to that, but we can't use the button 1 variable. The error message you'll get if you do this will look something like this, and you notice up here it says button 1 is not declared, it may be inaccessible due to its protection level. So you can kind of think of each of these variables as being kind of encapsulated in this kind of bundle of loveliness, and nothing from the outside world can go and touch that variable at all. If you try and do that, your variable is we say the variable is out of scope, and as you can see here it tells you, it gives you various suggestions here, none of which are in the slightest bit useful. Now that you can make variables incredibly localized. So as I said, they're local to a block of code. So if we look at this little example here, you've got one block of code which is the subroutine, it's a private sub all the way down to end sub. And then if we run down, and you notice we've got this variable called button 1 variable at the top here. We've then got this if statement, so it says if true then, we then have a lump of code, else, message box, and then end if. And you'll notice in the true part of the if statements, this part at the top here, we have defined a variable called if variable. And we're using that in this first message box statement here, and it's absolutely fine about that. But when we go down to the second message box statement here, it says it's not declared, it may be inaccessible due to its protection level. And that is because this variable here gets allocated when we enter this block. When we exit this block, it gets deallocated. So it doesn't actually exist down here. And that's why we're generating the error message. Now, just to kind of sum up, all constants and variables in computer programs have a scope. All should be given meaningful names. We should prefer using local variables rather than global, so you should always try and use local variables where possible. It is possible to pass values from one subroutine to another using parameters and arguments, which we'll kind of cover in some other time. And you will generate syntax errors in your programs if you try and use a constant or variable without scope. In Visual Studio, it will tell you that the item is inaccessible due to its protection level. So what that means is you've probably got a scope error. A syntax error is you're breaking the rules of the language. So that's what that's all about. A few little tips for you is generally speaking, when you want to write code, you want to write define all of your variables at the very start of your subroutine. So I would usually expect to see a declaration saying here's a function or here's a subroutine, and then straight after that I like to see all the variables declared at once. What is bad practice is just declaring the variables as you kind of need them, because then they get kind of scattergun throughout the code, and it's very easy to then generate scope errors. It's also very difficult for other people who are reading the program to actually check variable declarations and the like. So do them all in one go at the start of the program. Secondly, it's a good idea to initialize all your variables when you declare them. So we've got an example here at the top: int day equals 1. So this is a C type declaration, declaring an integer called day and giving it the value 1. And then underneath that, we've got a declaration for Visual Basic declaration. So again, this is defining a variable called day, and it's giving it a value of 1. And another tip is generally, I would say, avoid using highly localized variables, because they can generate errors, especially when you want to subsequently modify your code.